Good day, viewers. Welcome to my YouTube channel. Okay, this is your tutor, Mr. Mlenga. So we are still looking on Earth geometry. Okay, this is our topic, Earth geometry. Now we are on lesson 3. Okay, we are now on lesson 3. So meaning we have done lesson 1 and lesson 2. Okay, now we are on lesson 3. And under lesson 3, we are looking at how to calculate the length of an arc on a line of longitude and the line of latitude. Okay, meaning we are looking at how we can find the distance along the line of longitude, which is the great circle, and along the line of latitude, which is the small circle. Okay, so let's see. Here we have the Earth model. Okay, we have the Earth model, and this Earth model is having the great circles. You can see the longitudes here. Okay, we also have the latitudes there, small circles. So all longitudes are great circles, okay, and all latitudes are small circles, except the equator, meaning that the equator is a great circle. Okay, so here now we have this point A and point B, and down here you can see we have point M and point N. So I'll start with the first point there on top, okay, for A and B. So now here we have point A and point B. Okay, so meaning how can you point A and B? In short, I'm talking about the distance from A to B. Okay, and when you look at this point A and B, they are lying on the same longitude. They are lying on the same longitude, which is a great circle. And since this is a great circle, it's going to use the radius with the capital letter R. R is the radius of the Earth. Okay, and if you go back to the previous lessons, I did mention that the radius of the Earth can either be in kilometers or Newton miles. So it depends with the radius of the Earth that they have given you in the question. Okay, so now when you look at this line of longitude, when you look at this line of longitude, the great circle, where we are having point B and the point A, as you can see, from this line, okay, you can see we have this line passing, and we also have another line passing. These latitudes, okay. So when you look at this, the way they have been formed, there is an angle which is obtained here. Okay, this angle is theta. So this angle is the difference in latitudes, because here there is a latitude passing moving down there. They are sharing the same longitude. So this theta is the difference in latitude. Okay, so now how can you find the distance from A to B along the same longitude? So let's see the formula that you can use. So it's very important that you understand the formula that you can use to find the length of an arc on the line of longitude, or the distance of line AB on the line of longitude. So what formula can we use? Okay, what formula can we use? So the formula we can use, we can say AB, since we want to find the length of an arc from A to B, from this point A to this point B, okay, is equal to, or the distance from A to B, equal to theta over 360 degrees times, okay, 2 pi r. Okay, so this is the formula that we can use if you are finding the distance along the line of longitude. Okay, so now let's see this theta. What is it? Remember what I said? Theta is the difference. Theta is the difference in latitude. Theta is the difference in latitude. Okay, between point A and B. And we all know that this is a great what? Circle. Okay, so theta is the difference in latitude between point A and point B. So you can see the latitude is passing here, another latitude there. So the difference of this line of latitude for B and the difference for that line of what? A, that is the theta which is here. Okay, so now what about this R? Remember what I've said, R is the radius of the great what? Circle. R is the radius of the great circle. Okay, which in this case we are using 370. So it depends with the radius that you are using, and here is a great what? Circle. So now we are going to look at an example on how we can apply this formula. Okay, we are going to look at an example. Now we can apply this formula. So as you can see, I've got a paper with me. Okay, so this I'll draw it the way it is, so that we see how best we can answer our question what? A. So that we see how we can apply the formula. Please take a look at it nicely. Okay, we use this. Okay, so I'll draw this, I'll make a sketch, and then we see how best we can answer it. Alright, so as you can see, I showed you people this, that you are going to answer this question. Okay, this is the question that I've just drawn. This is the one. Okay, so for this question they're saying in the diagram below, A and B are points on the latitude 60 degrees north, while C and D are points on the latitude 60 degrees south. So take pi. Okay, they have said our pi should be 3.142. Okay, our pi should be 3.142. Our pi, okay, take a look at it here. This is the question I'm reading. So our pi should be 3.142, and the radius should be 3437, which is in Newton miles. So here, if they have given you the radius in kilometers, the value would change, not this, but it will be 6370. So take note of the value of the radius that they have given you. Okay, so the value of the radius there, they have said it should be 3437 in Newton miles. Very important to understand these points. So the question is, calculate the distance BC, okay, along the longitude 60 degrees east in Newton miles. And this question normally was carrying 2 marks. Remember, this is the question from the past paper. So what you do, identify your lines. Okay, you identify the line BC. Okay, so let's identify. So before we identify, allow me to wrap this part. Okay, BC. Okay, so where is BC? Where is BC? So we can see that point B is there, point C is there. Okay, so this is the line where BC is lying, and this line, it's a longitude. Okay, this is a longitude. They are lying on the same line of what? Longitude, which is a great circle. So what is the distance from B to C? Okay, so what you do there, you write B, come up with the coordinates for B. Okay, remember when you are writing the position, you start with latitudes. This is the line of latitude. Okay, so the latitude is 60 degrees. Okay, the longitude is this, which is 60 degrees east. We did this in lesson 1. Okay, then we come to C. The point C is here. Remember, B and C, they are sharing, or they are lying on the same what? Longitude. Okay, So here again to be 60 degrees what is, that is the longitude. Then for latitude, C is lying on this latitude, which is 60 degrees south. So upon doing that, then you come up with the formula. So what is the formula? Remember your points B and C, they are lying on the same longitude, okay? So we are finding the distance along the line of what? Longitude. So the formula will be the distance of BC is equal to theta over 360 degrees times 2 pi r. Okay, so this is the formula we are going to apply. Okay, so now remember we have to fuse in on theta. Okay, we have to fuse in on r, which is the radius, and the radius they have said it is 3437 Newton miles. That's the one we are going to put there. And if you remember for theta, I said this is the difference in what? Latitude. As you can see on our points here, same longitudes, these are cancelling, not then you're just having these latitudes. So you find the difference in latitude for 60 degrees north and 60 degrees what? South. Okay. So how do we do that? How can we find that difference? Okay. So I'll wrap here. Okay, I'm wrapping here. So the difference there for theta, I'll say for this theta, okay, this is the difference in latitude. We say 60. Now you can see these are lying on different side of the equator. Okay, so meaning we are going to do what? To add. Okay, we are adding. This one is lying on north, this one on south, different side of the equator. So we are going to add 60 plus 60, which will give us a 120 degrees. Okay, so this is the difference in latitude for theta. So we just now fuse in on the formula. So we say BC is equal to, where there is theta here, we are going to put 120 degrees over 360 degrees times, okay, times what is here, it's 2. Okay, allow me to rub here. Okay, okay, so 2 times, they have said the value of the pi should be 3.142 times the value of the radius, they have said it should be 3437. Okay, after you are done choosing in there, the next step now you say PC equal to, remember this is paper 2. Okay, so there is need for you to use the calculator here. There is need for you to do that. Okay, so what you do now, just get the calculator and we punch, we see the values that we are going to get. All right, so you just fill in everything on the calculator here. Or before we do that, we can cancel these zeros here, so that you remain with 12 over 6. Okay, times, then we multiply that. Here we say 2 times, I hope you are also multiplying. I might make a mistake here when punching on the calculator. Okay, so I hope you are following me, so that you also get different value. So this is my value that I'm getting. Okay, this is my value. I hope you did get the same value. Okay, so since this is paper 2, I'll just punch there. I'll say Okay, so for me, when I punch on the calculator, when I punch these values on my calculator, I'm getting this answer. Okay, I'll write it down here. I'm getting this answer. Getting this answer. Okay, I'm getting this answer. Okay, so what I'll do now, I'll write my final answer. I will leave this correct to 2 decimal places. Okay, so therefore BC equal to 7199.37. So this will make it 2 to be rounded up by 9. Okay, nautical miles. Okay, why am I putting this? Because they said the radius of the earth should be nautical miles. Okay, so this is our answer. Okay, we have found the length of B and what and C along the line of longitude. Okay, so now we are going to look at how we can now use, or how we can find the distance along the line of what latitude. That's where we're going to look at. All right, so that is how you can answer, or that is how you can find the distance along the points that are lying on the same what longitude. And don't forget the formula that we have used. Okay, now if you remember, I did say that we are remaining with this, finding the length of an arc. Okay, in this case we have this point M and the point N, so finding the length of an arc MN that is lying on the same line of what latitude, which is a small circle. Okay, so here we have the alpha. Okay, so you also have to understand, you can see this is the line of longitude, another line of longitude there, then they are lying on this same line latitude. Okay, as you can see, so it's like this. So these 2 points to longitudes are passed like this. Okay, then there is an angle which is subtended there. Okay, this is alpha. So this angle is the difference in what longitude. Okay, so this is what we are coming up with. Remember, this is the line of what latitude, which is a small circle. Okay, this is a small circle. So now what formula can we use if we want to find the distance or the length of an arc from M to N? Okay, very important. So let's see, write the formula that we can apply. Okay, so here you say the length of MN is equal to theta over 360 degrees times 2 pi r. Okay, so you can use this formula. Okay, you can use this formula. Now we have to understand this r, that is the radius, okay, of the small circle. Okay, remember what I've said, this latitude, it's a small circle. So the radius here, we're having the radius for the small circle. Okay, so theta is the difference. Okay, theta is the difference in longitudes. Okay, theta is the difference in longitudes of point what M and N that are lying on the same latitude, which is a small circle. Okay, then this r is the radius of the small circle. Okay, So you have to understand these 2 points, okay? You have to understand these 2 points. Very, very important. Okay, very, very important. So we are going to look at an example where we can apply this. Okay, we're going to look at an example where we can apply this formula. Then this radius will be also explained properly. Okay, so pay attention, be with me. All right, so remember I've said the formula that you can use to find the distance of the lines, okay, that are lying on the same latitude. This is the formula, okay, where we said the Mn equal to theta over 360 times 2 pi r. Okay, so I said this theta is the difference. Okay, theta is the difference in what? Longitudes. Theta is the difference in longitudes. Then r is the radius of the small circle. So now, how can we find r? So I've redrawn the same diagram that we had. How can we find r? So if you want to calculate now the radius of the small circle, okay, you have to look at the small circle passing through points M and N. Okay, so when you look at this, you're going to have an angle to be subtended from the equator here. Okay, so from this equator you can see what we have come up with. Okay, so I'll draw it. This is a right angle triangle, you can see. Okay, then for the angle, so consider the angle which is here. Okay, consider the angle which is there. Now remember, if the angle is here and this side you have the big radius, because coming from the equator there, you can see you have the radius there. Okay, this is a great circle. Now we are talking about the small circle. So here the radius of the small circle will be denoted with a small letter r, like that. So this is the one that we're interested in because it's part of the formula. Okay, so how can we find this? How can we find this? So we can find this by using the trigonometric ratios, okay, which we know we have over there. Okay, so the third ratio which is going to be applicable here, we can see this is the hypotenuse. Okay, if this is the hypotenuse, and then this is the adjacent. Okay, so it's this one. We're going to apply that, where you say cos theta, this theta is equal to, okay, here we have adjacent over hypotenuse. So I've said our adjacent is this value, okay, then our hypotenuse is this. Okay, so we want to find this, and this is the fraction, so we divide that by 1 so that it's also a fraction on this side. When we cross multiply, we are going to get something like this: 1 times r, which is the radius of the small circle, equal to this r cos what? Theta. Okay, so in other words, what I'm saying, where you have this, okay, where you have the r there, radius for the small circle, you'll be applying that, which is r cos what? Theta. Okay, then I'm sure you have understood. Now let's see how best we can apply this formula now in a practical method. All right, so we have come up with this formula. So now the final formula of this now will be, we say Mn equal to theta over 360 degrees times 2 pi. So where there is r, the radius of the small circle, we have said this is the one that you use, this one. Okay, so you write there r cos theta. Okay, so this is the formula you have to use when you are finding the distance along the lines, okay, that are lying on the same latitude. So now let's look at an example here. Let's look at an example. Calculate the distance QR. Okay, calculate the distance QR from here to here. As you can see, Q and R, they are lying on the same latitude. They are lying on the same latitude. Okay, so how can we find the distance? So they are saying this distance should be calculated in what? Kilometers. Okay, so take pi to be 3.142. Then radius, okay, should be 6370. The radius of the earth should be 6370 in kilometers. So when we look at here for latitude, for this latitude, it's 40 degrees south. This one. Then for this longitude, you have 30 degrees east. For this longitude, you have 80 degrees east. Okay. So the first thing, let's come up with the points. Okay. Just like what we did in the first example. Let's come up with the points. Let's come up with the points. Okay. So the points that you come up with, since we have been taught to calculate for the distance for QR, so we say Q, okay, we say the latitude, they're having the same latitude of 40 degrees south. 40 degrees south, comma. Now, what longitude? This P, on which longitude is it lying? This is the longitude, okay? You can see here, 80 degrees east. 80 degrees east. We come to R. So for R, I've said Q and R, they are lying on the same latitude. So even here it's 40 degrees south. Okay. Then on which longitude is R lying? This is longitude, okay, which is 30 degrees east. 30 degrees east. Okay. So now we know that we are going to use the formula for finding the distance along the line of what? Latitude, which is this formula down here. So this theta, I said the theta is the difference in what? Longitudes, because these are going to cancel. They only remain with the longitudes this side. So the theta there will be, you can see they are lying on the same what? Greenwich meridian, which means you're going to do what? To subtract. We say 80 minus 8. Difference in longitudes will be 50 degrees. Okay, so where there is theta here, for this theta, we're going to put what? 50 degrees. Okay, can we proceed? Now, okay, this is the distance. Sorry, this is the radius of the circle, which have been given, which is 6370. Okay, 6370. Now, you can see we're having another theta this side. We're having another theta this side. What value are you going to put there? Okay, what value are you going to put there? So the theta here will be equal to what? What is the latitude you have been given? And you see they are lying on this latitude. So put what? Okay. So after exhausting all these points, then just using this on what? In the formula there. For the pi, they have told you that the pi should be 3.142. So you just using all these in the formula. So how can we do that? How can we do that? Okay, now here, how can we do that? So we can write this formula. How can we do that? Okay, so let's say we are calculating for QR. So okay, say QR is equal to theta over 60 degrees times 2 times R, sorry, times pi times R cos theta. That is our formula there. So we said this, we put that 50 over 360 times 2 times 3.142. Okay, 3.142. Okay, then times this is the radius, which is in kilometers, 70. Okay, then we say cos. So here I said you put the value there for the latitude, which is 40. Okay, Okay, this is what you're going to come up with. So for the next step, just a matter of what pressing or entering these values in a calculator. Okay, or you can start by, you can cancel this and this here. Okay, just to reduce something. Then if you want to multiply this, then you come and do it together with this value. Alright, so this is where we are. Now just an emphasis here. So I've seen maybe some of you can be confused on the formula there. When you write the formula, you say theta over 360 degrees times 2. I'm making an emphasis by r cos. Here you can just put x. Okay, I'm putting x there so that we create a difference between this theta here and another. Yeah, so I'm creating a difference here. So this, you can use this. Okay, I've just put a letter there. Okay, and this letter which is there, I'll say this x is an angle in what? Latitude. Remember, we have been given the latitude here. We are lying on 40 degrees. Okay, this is why I was even putting 40 there. So this is an emphasis I wanted to make so that you get the concept clearly, because I know I put theta here for me, or others, they might understand. Okay, but others can get confused. They might put the difference in longitude here. They also maintain, no, that's not the case. So that's why I've decided to show you this other one. Okay, so now let's proceed. We have ended on this stage. Let's proceed. Okay. So if you have a calculator, you can start. So here we have QR equal to 5 over 36 times. So I'll multiply these. Okay, 2 times 3.14, 2 times 6370 equals 40. The value that it will give me, I'll write it there. Okay, so you can also do the same as I am applying, so that we see if the values will be the same. Okay, or if mine you have a different value. Okay, so for me, when I multiply, I'm getting this value. Okay, getting this value. This is the value that I'm getting. Okay, so to come to the final answer, this value that I'm getting, I'll just now try it with this. Okay, try it with that, which is here. Then I'm going to get something like this. I'm going to get something like this. Okay, so for the final answer now, say therefore, remember I said you can leave our answer correct to 2 decimal places. Okay, correct to 2 decimal places. So this will be 2, 5. Now, before I go there, I know that the 2 decimal places will be these. Okay, now this 9 will be rounded off by 6. So it will be 10, meaning it will be above the 0. The 1 will be there. Okay, then point here, 8. So kilometers. This is our answer. Okay, so I hope you have gotten this answer as well. Okay, so this is how you can know the line of latitude. Okay, let's not forget the formulas that we can use for the line of longitude and for the line of latitude. Very, very important. So I'll leave some questions with you so that you can try to answer them.